All right. Hello, everyone. Hope you're all having a good week so far. Today, we're going to talk about for loops and range. You can just think of this as another way to loop through a sequence. When we talk about sequences, we're talking about things like strings. We're talking about things like lists, which you've been working with for a little while. And we're also talking about things like dictionaries, which you just learned. Uh, for in loops, we think of as just kind of a very efficient way to loop through a sequence. With a while loop, we needed to declare an index and then set up this conditional that had to evaluate to true in order to be able to step into. And then we used that index with the subscription notation to access a particular element. So, for instance, the list of strings XS has four string values in it, has four string elements in it, and they each have an index, right? So this is just some review. W is 0, X is 1, Y is 2, and Z is 3, right? And so if I were to want to print every element in that index, I would have or in that list, I would have to create my index. I would have to set up this loop that says while this condition is met, this condition being IDX is less than the length of XS, which the length of XS is equivalent to 4, right? Uh, while this is true, execute what's underneath. So the first time we loop through this, XS at index 0, right? Because IDX in this case is 0, would be W. So our output would be W. Oop, W. Okay. Then we increment IDX by 1, so IDX becomes 1, and we loop back up, and we check the condition again, right? So the condition IDX of 1 is still less than the length of XS, which is 4, so then we step back in and we print what this evaluates to, right? This evaluates to XS at IDX, which is now 1. So XS at 1 is X, so we would print X. And so on and so forth. Ultimately, IDX increments by 1 again. So this becomes 2. And we would end up printing Y. IDX increments by 1 again. And we would end up printing Z. IDX increments by 1 again. And of course, when we loop back up, 4 is not less than 4, right? So we can move on to the next line of code. Look familiar? Cool. So with for loops, if we wanted to do the exact same thing, all we would need is just two lines of code, particularly these two lines of code. And the basic anatomy of a for loop is think of this as for every element in the thing we're looping through, right? So for every element, in this case, we're using the word elem to represent it. Uh, inside of XS, which is the sequence we're looping through, do something. In this case, print elem. Right? It's indented underneath because once we're done looping through everything else, we want to move on to the next line of code. So uh, lm, in this case, you could think of as a temporary variable that's created in the stack, and it's set to whatever the element is, the first element is in the sequence we're looping through. So on the first iteration, lm is going to be w, right? And then it would print out. W. So as soon as elem is assigned to W, it steps in and it executes whatever is indented underneath this for loop. We're not done. We haven't iterated through every single item in XS, so it loops back up. Elem is now set to the next element in XS. So in this case, X. So elem now becomes X, and then we just step in here and print X. Still not done. There's still two more elements in XS. So LM gets reassigned to the next item, which is Y, and we get Y assigned to LM, and then it prints out Y. And then finally, I'm sure you see where this is going. LM is now assigned to the last item in XS. So LM gets assigned to Z, and it prints out Z. Pretty simple, right? Kind of saves us having to worry about this index. Saves us having to think about this equivalency. It saves us having to increment IDX. All that's taken care of with this for LM in XS. Just think of one really important thing to note is that LM can be anything. Right? We used elem, just the word, to denote every single element in this list, right? But elem could be any word you want. So I could say for dog in XS, right? Print dog would have the exact same output. It'll make a little bit more sense once we get into a memory diagram, but essentially, you are just picking a variable name to represent every single element in XS. Dog refers to every element in the sequence XS. Now you can't pick whatever you want for XS, right? XS is the list, that's the name of the list, that's how we're referring to this list in our code. If we want to loop through every single item in that list, we have to use XS, right? If this was named cat, right, this would have to be cat. But we could change this to LM, we could call it blah, we could call it, yeah, you get the point. Really anything we want. Cool. Let's move on. So this slide is just kind of comparing and contrasting what how IDX is different from LM when we're comparing while loops to for loops, right? So a while loop you could think of as iterating through the indices of our list, right? So this is the exact same list we had up here, right? It's named XS. Uh, the while loop iterates through every single item or index in here, and then we use that number to access specific elements in the list. We could also just have it print out the index. So like this loop, instead of printing out every single element, prints out every single index. So on the first loop through here, IDX is 0, right? So it steps in, oops, it steps in and prints IDX. Well, IDX is 0, right? So it's going to print out 0. IDX then gets up to 1. 1 is still less than the length of IDX, which is 4. So we print out 1. And IDX gets incremented up by 1, so on and so forth. LM, as I said before, up here, is looping through the elements in the list, not the indexes. So if I decide to print elem, it's going to print out every single one of these elements in this list. If you are asked in a quiz or in a challenge question or some lesson what type elem is, you can think that elem is always going to be the type of the element that the sequence is made up of. So W is a string, and we have a list that is a list of strings. So we know that elem is of type string because it is a list of strings. All right. Let's work on a memory diagram for this. I think some of this might make a little bit more sense once we dive in. All right, so memory diagrams are read top to bottom, left to right, and inside to out. So let's start at the top. Our first line, we have docstring, practice of for loops. Human read code, computer just kind of skips over it. So we move on to line 2. Line 2 is blank. Move on to line 3. Line 3 initializes a list. It's going to be called myList. So we're going to give it the name myList. It is of type list of strings, and it's set to the list hello, comma, and the string world. So we're going to go over to our heap. All right. And it is going to be a list of strings. We're going to give it an ID of 0. And it has 2 values in it. It has the string hello. It has the string world. This might be reverse for some of you, but I think it's important to note this is the first index, this is the second index. So the first index slot goes to hello, and the second index slot goes to world. Cool. And then finally, we have to know where to find it in the heap. So we take this little ID and we store it as the value of myList in globals. Just a little review. We know it's in globals because it is furthest to the left here. If there was like a function, inside, indented inside, and we were inside that function, it wouldn't be in globals. But all right, cool. So we are done with line 3, and so we're ready to move on to line 4. Line 4 initializes a new list. So we're going to go through pretty much the same process here. We have new list. We're going to give it an ID value, but we got to first create that. We're going to come over to our heap, and we're going to start making a list. Now, our list, if you look ahead, doesn't have anything in it. Doesn't mean we can't make the outline for it, though. So we give it its type, and we know it's going to be a list of strings because we've explicitly typed it. We've said, hey, this is going to be a list of strings. and we can give it an ID. I'm going to give it ID 1, it's the next one available. And we're going to store that ID, that pointer, in new list so we can find it later. Cool. Nothing else goes in here because there's nothing in here. It's just hanging out ready for us to put stuff in it. Cool. All right. So now we're done with line 4. And we're ready to move on to line 5. And line 5 is the first time we are memory diagramming a for loop. Cool. We first need to determine what we're looping through. Well, we're looping through my list. Well, what's my list? Well, my list isn't this. This, for my list, is just pointing to this whole list in the heap. So when we say, hey, for every element in my list, that takes us over to this list. But we do have to define elem. Elem is the keyword. This is the variable name that we're going to use to refer to every single item in this list. So we create an elem variable slot. And we're going to make a little bit more room. Create an elem variable slot, right? And we are saying, okay, for every item, for every item in my list, do something, right? Well, we don't really need to look down here to know what elem is going to be. Elem on the first loop through is going to be the very first element in our list. So elem is going to be set to the string hello, because that is the first item, the first string, the first element in the my list. Cool. All right, so we've done that. Now let's see what this for loop wants us to do. Well, our for loop calls the append function on new list. So it's saying, hey, take the value stored at elem, which is hello, and append it to the list new list. So we're going from new list down here. We're taking the value stored in elem, which is hello, right? Sorry, that was probably misleading. We aren't actually looking at this on line 6. We've sourced this string, stored it in elem, and we're saying, okay, take elem and append it to this list. So we add an index of 0, was the first element in our list, and we're going to put in the string hello. Cool. At this point, we're done with that indented block. We're done with everything that this loop wants us to do on the first iteration, and we loop back up. Now, elem changes to the next item in that list, so it becomes world. Cool. After that, we step into our for loop, and what are we doing? Well, again, we're taking elem and we're appending it to new list. New list takes us here. We're appending elem here. So we add another index, and we're going to put in the string world because that is what is stored here. Cool. All right. Now, we are actually done with this for loop. We have looped through every single item in my list. And so we can move on to print. Now, print basically just says, hey, take this new list and turn it into a string that we can put in output. So our output is going to print the contents of this list right here, because this list ties to new list. And that's what we're printing. So our output is going to be hello world. That's it. Quick side note. Uh, when we print out strings in output, we normally don't put the quotes around them, right? Because, whatever this stir is, because that's not really what we see in the terminal. However, if you try to print a list in the terminal, uh, you will notice that there are these little quotes here. And that's to signify that this list right here that's getting printed is a list of strings. So when you're making your memory diagrams, make sure that you do have some sort of quotes around these strings if the list that's getting printed is indeed a list of strings. Same goes with dictionaries. Cool. All right, let's move on. Let's try to write a for loop. So we have here a list of strings. It's going to be called pets, and it's the name of these pets. These very, very cool names for these pets. All right, cool. So using a for in loop, write code to tell each pet they're a good boy. Call each element something other than element. Cool. This goes back to the idea that the part of the for in loop, this part right here, we can name whatever we want. So we've been naming it Elm. Let's name it something else. So we can just kind of assume that this is already in our line of code above it. And let's create a for loop. What do we want to call it? Well, I have a feeling that these are the names of dogs. Not that Bear or Bo or Louie can't be the name of cat. In fact, Louie does sound like a really good name for a cat. But let's just call this dog in pets, right? We are looping through the pet list, and every element is going to be temporarily referred to as dog. Cool. So what do we want this to do when we step into it? Well, we want to write code to tell each pet that they're a good boy. We want the output to be good boy Louie, good boy Bo, and good boy Bear. Well, key hint here is output. So I know the first thing I'm going to want here is a print statement, right? Uh, so we want to print good boy and then space, and then we want to concatenate on uh, sorry, dog. We can do this because dog is a string. If dog is every single element in this list, and each element is a string, and we're just concatenating on dog onto good boy. So if you think of this in like a little memory diagram, you got your stack, you got a heap, pets is over here. On the first loop through, dog is going to be Louie. On the second loop through, dog is going to be Bo. And on the third loop through, dog is going to be Bear. Cool. Hope this makes some sense. Let's move on. All right. Why while loop over a for loop? Well, while loops allow you to access specific indice ranges, whereas the for loop we've learned so far has you loop through every single item in the list, right? So if I wanted to use a for loop, a for in loop on this, it's going to execute whatever is underneath of it on every single item in this list. Now, the way we've set, actually, oh, no, we don't. All right. Whereas for this while loop, it, as it's set up, is going to loop through every single index in this list. But we could just as easily say, hey, I don't want to loop through every single one. I want to skip actually the first two. So I'm just going to make IDX2, and then it's just going to loop over these two. Pretty useful. A little bit more accurate than just kind of brute force looping through everything with this for loop. But the for loop does make it allows you to loop through lots, or through the entire list. However, there is a workaround this. If you really hate while loops and you want to work with for loops only, we have something called range that we can use to be a little bit more articulate with our for loop. So uh, a range basically just stipulates what type of sequence you can loop over. We can specify where we start, and then we can specify where we end. And then we can also specify how we increment. This is done with this constructor. We're basically creating this range. Think of range as creating a sequence of numbers that will be acted on. So we have our start. Let's say this is 1, 2, 3, 4, 5, 6. Right. We have our start. So we would say start is 1. Let's say we want to end on 10. So end would be 10. And we want to look at every single number in here. So we would set our step to 1, which means, okay, every time we loop through, we're going to be going 1 increment up. Very similar to specifying the incrementation of IDX. So if I wanted to loop through numbers 1 through 4, I would simply, sorry. The end is never acted on in a range function. So if you say start at 1, right, and go to 10, if I want to start here and go here, it's going to act on 1, 2, 3, 4, 5, 6, 7, 8, 9, but not 10. Cool. So if I wanted to, if I did range 1, comma 5, the start is 1, the end is 5. So the action is going to stop at numbers 1, 2, 3, and 4 and skip 5. The step by default is 1, so we don't actually include it as the third argument in this range function. If we did, we could say, hey, let's put 1 here. You don't really need to. The only time you need to is if you want to increment it in a way other than 1. So if I wanted if you wanted the range function to stop at 1, 3, and 5, I would have to start at 1, right? I wanted it to stop at 1, 3, and 5. I would need it to stop at 5, which means it has to go to 6, right? Because it's non-inclusive at the end. And 1, 3, and 5 are a difference of 2, so my step is going to be 2. So we start at 1, we end at 6, and we step by 2. So it's going to go 1, 3, 5. Make sense? All right, cool. Don't really have to worry about range in memory. Yeah, don't worry about it. Cool. But as you can see, this allows us to iterate, well, maybe as you may not see, but this allows us to iterate over index using a for loop. So what we've been talking up until now has been looping through the elements in the list. But if we constructed a for loop that said for IDX in range 0 to the length of my list, it's going to loop over these indices. Now this doesn't seem like it makes a lot of sense, but let's break it down. So IDX, again, is just an element, right? We can call it whatever we want, I believe, but we often just say IDX because we want it to refer to the IDX, the index of that uh, structure list that we're going through. So it's going to start at 0, and it's going to go all the way up to the length of my list. Well, the length of my list is 4, right? Well, there is no 4. What the hell? Well, because range goes up non-inclusive, we don't actually ever do anything with that 4. So whatever is executed underneath this for in range loop is going to be, we're going to use IDX to do so. So I could just say, this is my list. So I could just say print my list at IDX, right? Right? And this would print every single element in that list, right? It's doing the same exact thing we did with while loops. We're using subscription notation to access every single element in this list. Now, if I just said print, IDX, now it's going to print every single index. Very similar, well, identical really, to what this while loop is doing. You can use range to do the same thing you would with a while loop. This slide just kind of basically goes over what we've already talked about. It's kind of more of a full breakdown of what you've learned so far. So we can use for in range to print out indices. We just print out the index. We can use for in range to print out the elements. We have to use subscription notation because for in range IDX, this keyword right here refers to the indices. And then we can just use a for loop, which we learned at the beginning of this lesson. And elem in this case refers to the elements in the list. So 3 different for loops you can build up. 2 of them print out the same thing, but they use different ways of doing it. This one uses subscription notation. And yeah. One thing to note before we build this last for in loop is step can be anything you want it to be. So we've used step to talk about we've used that very simply for 1 as the step or 2 as the step, but I could say for IDX in range length of XS, comma 0, comma -1. And what do you think it would do there? Well, it's going to start at the length of XS, right? So it's going to start at whatever is returned when you call the length function on XS. So, and it's going to, oh wait, sorry. My mistake. We can't really do that, can we? Because let's say XS is a list of letters. 1, A, B, C, D. Right? If we want to start here and work our way back, well, the length of this is 4, right? If we want to start at the last letter, we have to do the last index. So we'd have to start at length of XS minus 1. Now this whole thing right here evaluates down to 3, right? Length of XS returns the value 4, minus 1 is 3. So our start is 3. We want to go all the way down to 0, right? We want to print A. Let's say we're doing a print uh, XS uh, at IDX. We want to print every number or every letter. We want to go down to 0, right? But remember, range is non-inclusive, so our last stopping point we want to hit is actually -1. And then if we increment by -1, it's going to work its way back. I really hope I explained that well. I may not be the best way of explaining it, but I think it's a really important tool that you can use with for in range, and I think being able to see it at least once might help in the future. So, okay, cool. Let's just work on this last slide here, and then you'll have a good footing for working with for in loops. Excuse me. So we have built a list. It's a list of strings. We know it's a list of strings because it's been explicitly typed, and also every single element has these quotes. Cool. We want to print every element's index and every element's value. Cool. So we're going to use a for in range. Oh, and we want it to ultimately print out this line of code, these 3 lines of code. So we're going to say for IDX in range. Where do we want it to start? We want to start it at 0, 1, 2. We can always check. Cool, yeah. So we want to start at 0, right? We want to print a 0 and Alyssa, right? And where do we want it to end? Well, we want it to end at 2. There's a couple ways we could do this. We could say 3, right? This, because it's non-inclusive, it's going to go here, and here, and here, and well, 3 is there, but we don't really have anything to print, so it's going to stop at 2 because for in range code is non-inclusive. So we could say that. We could also just say the length of names. And this is the preferred way to do it. Because say you're building a function, Your function wants to be able to handle lists of any size. So using length of names allows us to have this work for any list. And then we want to increment by 1, right? Because we're stepping up by 1. Now I put it in there. We don't really need it because we're just incrementing by 1. Cool. So we have our for in range loop built. Now we want it to execute these print statements here. So we're going to say print. Well, what's the first thing we want to print? We want to print 0, right? Well, what is 0 in this for in range loop? It's IDX, right? IDX in a for in range loop refers to the index of the data structure we're looping through. So we would write IDX. Oh my goodness. Ah. I believe we would write stir IDX, right? Because IDX is a string or an int value, so we have to turn it into a stir, right? And then plus, now we concatenate it with a colon. Oops. Concatenate with a colon and a space, right? Because there's a space right here. And then we concatenate it with, well, Alyssa. We need to access Alyssa. Well, on the loop, the only thing we really have access to is the index value. So we use the subscription notation to access the string. The name of the list is names. And then we're putting the IDX in the brackets to access, the value at that list, at that index value. Cool. So we create this for loop. IDX refers to every single index. It goes up to the length of names, which is 3. But since range is non-inclusive, we're good because we only really wanted to go up to 2 anyway. And then we're just concatenating these values together in our print statement. Stir IDX gives us IDX for every single iteration through the loop. So in the first loop, it'll be 1, or excuse me, 0. So it'll print out 0. It's going to print out a colon with a space. And then it's going to print out names at index. Well, IDX again is 0. So it's going to names and grabbing the element at index 0 and popping it in here. So the first loop through will be 0, colon Alyssa. Second loop through, IDX changes to 1. And when we access 1 at names, we get Janet. So the second print statement will be 1 colon space Janet. And then finally, IDX changes to 2. And so it prints 2 colon space and then accesses names at 2, which is Brenda. And then we're done. Cool. I hope this has been helpful. If any of this is confusing, please reach out to office hours. We're always super thrilled when we see a Zoom link pop up. It means we get to help someone kind of figure out what's going on with their code, which is always fun to debug, or just help someone kind of explore a new concept. And so much of the time we're just kind of staring lonely at a chat screen. So please don't feel deterred from reaching out for help. If you're confused or want to go through more examples, we can certainly do tons more diagrams. We can help you debug your code. And if you're really bored, we can even chat about your day with you. Not really, but anyway. All right. Thank you so much, and good luck with the rest of the week. All right. Bye.